Hello, everyone. Welcome to our next online workshop here at Polkadot. So for those of you who don't know me, my name is Bill Laboon. I am the Technical Education Lead here at the Web3 Foundation. Today, we are going to discuss Polkadot accounts as well as keys, which are somewhat related, but not exactly the same thing. We'll go quite into depth on different ways to generate keys and store keys, as well as what the different kinds of keys and accounts are for, because Polkadot does have a few different few different kinds of keys and accounts that do special things. And I want to make sure everyone understands what these different accounts are, as well as how can you generate accounts on your own and keys, and which kinds should you be generating or producing on your own, and in what manner. So before we start, and welcome everyone. I see a bunch of people coming online now. I really like to have questions, and with Crowdcast we have a really cool feature where if you click on Ask a Question, it should be at the bottom of your screen in Crowdcast. It just says ask a question, and then ask a question or suggest a topic. So I'm just going to ask, why is Bill so awesome? So there now will be a question. If you should be able to see it there, I can answer it, and that way later when people are looking at this Crowdcast recorded, they'll be able to go directly to where that question was asked and where I answer it, in case that you are interested in that. It also lets you sort of batch questions. I'll stop about every 10 minutes. I've got pauses built into the presentation, so you'll have a chance to ask, for me to answer your questions, so you don't have to wait till the end. So if you do think of a question, please feel free, click on Ask a Question, and I will answer it as soon as you can. Thank you for that pointer there, Dan. All right, so I think it's about time where I can start sharing my screen here. 1 second while I do all my clicks. Okay. So we are now screen sharing. Why is it? There we go. Why is it not going full screen? Sorry, hold on 1 second. It's always, every time you go to, because I clicked on full screen instead of present. You can practice this as much as you want. As soon as you start doing it in real time, you're going to make mistakes. All right, so first I want to discuss, what is an account? So we probably use this term, but we've never really thought, you may not have thought deeply about what actually is happening when you have an account. So the basic idea is we have some source of randomness. We definitely want to have something external, from the system, from rolling dice, from from whatever we can get a source of randomness. And what Polkadot does is creates a seed. So unless you use subkey or you're very into the code, you'll probably never see this seed. What you're going to see is a seed phrase, which is just an English language interpretation of that seed. You can almost think of it as like a base 2048 number, where each word indicates some particular super digit. And you'll see the public key, which is part of the address. So whenever you've made a Polkadot account, you've probably seen that you get some mnemonic phrase or seed phrase, and you have some address. So really what is happening here is after we generate one value, the seed, based on some randomness that gets input into the system, Polkadot is going to do three things. It's going to create a private and public key that is a standard cryptographic key pair, and it's going to print out or otherwise give you the seed phrase, which is just really another way of displaying the seed. The seed and the seed phrase, if you've seen like a raw seed perhaps in Polkadot.js, these are really just two ways of showing the same thing. The seed can always generate the private and public key. So we don't need to really keep the private key around anywhere, and you'll actually see that is generally only used internally. It's usually not exposed to the user. The public key is taken and for Polkadot and Kusama, converted into an address. So this address is in a format called SS58. And this is, we'll discuss about what exactly that is. But if we think about it as just sort of a wrapper around a public key, that wouldn't be too far off from the mark. So here is an example of a normal account. If any of you are familiar with subkey, this was generated with subkey. So you'll notice the secret phrase or your mnemonic phrase, that's really just another way of saying that secret seed. It's just some way of storing some string of bits. You have a public key, which again is generally not seen by a lot of end user applications. And then your address in the SS58 format, which is something that is generally seen. So SS58, if you're familiar with Bitcoin's check 58, it's very similar. It's in base 58. So instead of base 2, which would be binary, or base 10, which is decimal, base 16, which is hexadecimal, etc., it's in base 58. So it goes from 0 to 57, and then the next number. So this is the same scheme as Bitcoin uses. Inside the address in this format is really 3 items. There's the address type, which is not exactly, but for right now, you can think of it as saying which network am I going to connect to? I just want to put an asterisk there. It's not exactly what it does, but we can think about that for right now. The actual address, which is just the public key, as well as a checksum to make sure that you entered the data correctly. So if we take, this is a standard Polkadot address or Kusama address. And if we take the SS58 form at the top, 5, DM, HB, etc. Remember, that's just in base 58, which means that we can convert it to some other base, which is which I did so because it's going to make it much easier to understand. So you'll notice that first byte there, so I just turned it into hexadecimal, so every 2 characters is a byte, is just the address type. So that's saying, all right, what kind of address is this? That second big chunk is the public key. So this is what most people think of as an address. It's the public key from the cryptographic pair that you generated. And finally, there's a checksum, those last 2 bytes there, A77D. And what the checksum does, in case you're not familiar, it just makes sure that you typed everything correctly. So if you have a bad checksum, you'll know that there is a typo somewhere. You'll notice that public key, if we go back 2 screens, is the same as the public key from when we generate with subkey. So that OX38E1BF, and we see here 38E1BF. So if you're ever curious, what happens when you take apart a Polkadot address, there it is. So address types, as I mentioned, are you can think of them as almost like a network indicator to make sure that if you try to, let's say you have a Kusama address and you try to enter it as Polkadot mainnet, you'll know that it's something different. It's a different network. So again, you see this on a lot of other systems where the testnet and the mainnet have different prefixes. However, Polkadot and Substrate, rather more generally, this is a little bit more powerful. So you can actually say not just which network you're associating with, but also potentially what kind of cryptography you're using. You could have different size addresses, etc. But because it doesn't have to be for the same network, because you can see we have a sort of generic substrate, and substrate allows you to generate lots of different blockchains. So you could have multiple networks with the same address type, although that would probably not be, you know, a great idea. So we also could say, well, hey, I don't want to do this with a checksum for one reason or another. I just want to, you know, put a raw key up on there or something like that. There are also other different formats. There are actually quite a few different formats. The first, there are, I'm trying to think exactly how many, maybe about 20 or so that are already defined. But since, of course, we have an entire byte to play with, that means 255 possible different address types. So one thing about addresses that I also want to talk about, you've probably seen if you tried to generate an address and it asks you, well, do you want to make an ed 25519 or SR 25519? Which kind of cryptography do you want to use? So I just want to briefly explain what these are. Polkadot uses elliptic curve cryptography. So what that means is we have a curve that is defined by an equation, and we take a point, you know, instead of trying to factor numbers like we would do with, you know, what many people think of as like traditional cryptography and factoring primes. Instead, we take a point somewhere on this curve and try to figure out its discrete logarithm, which, just like factoring a prime number, is something difficult. Factoring for primes is a difficult thing to do. The ED 25519 versus SR 25519 are just slightly different curves that have different benefits and drawbacks to using. So they're different equations, which means that different curves will be formed, which means that you can have, depending on the type of curve, you can have things that are easier or harder to do in cryptography. So not to go too deeply into this, because I'm not a mathematician and I don't want to make any mistakes, but I will say that the ED 25519, they are tend to be better supported by hardware wallets and probably will continue to be. SR 25519 is going to allow for some of the more complex cryptographic operations that we do to be safer. If you're generating a normal address, you know, that is, you're just an ordinary user, you want to store dots, you're going to vote in governance, anything like that. Really, either one is fine. Session keys, because they do something more complicated, need to be certain types. If you're not running a validator, then you're probably not very concerned with session keys. But we should talk about them just so you can see, you know, what they are and why they're different. But just know that these ED 25519 and SR 25519 are both just the same kind of cryptography, albeit with different curves. So one thing I wanted to mention also about addresses, behind the scenes, addresses actually map to internal index values. So it's not like Bitcoin, if you're familiar with that, where really the address is sort of stored relevant or obtainable directly from the chain. So they're actually mapping to an index value that increments, which is actually very useful for doing things like looking for all addresses on the system and for saving storage space, since we don't need quite as big a value every time we reference. If we can just reference an index as opposed to referencing some very large cryptographically hashed value. So you can get these index values, but we generally don't recommend it unless you have a very, very specific need, which most people would not, because indexes can be reused if the existential deposit isn't reached. What this means is if your deposit in an address goes below a certain amount, it will be what's called reaped. That means taken away. So if you have less than something like 100 millidots on Kusama, you will get reaped, which means that address will no longer have an index. And so it's fine if you have that address still with you. You want someone else to send you dots to that address because it'll just generate a new index. But if you shared the index directly, then someone else could have taken that index and somebody would get the dots that you may have expected. Okay. So always just make sure to use your address. Unless you're really sure for one reason your account will never go below the existential deposit. But generally, always use the address that you generated. All right, so I'm gonna pause here for a second to see if there are any questions. Which I can't see, but there we go. 4, okay, excellent. All right, so. Okay. Oh, share the presentation after the webinar. Yes, as Dan mentioned, the presentation is saved on Crowdcast, and apparently it's being live streamed on YouTube. So hello, YouTubers. Wow, how to describe to my mom what is Polkadot and why she should use it? Well, that's a really good question. I would. I mean, I don't know your mom, so if she's an engineer, then we could get definitely into depth. But if you're saying just a non-technical user, Polkadot, I would say one that this isn't really the kind of question I was expecting when talking about addresses. But it is a way to do a lot of different things with blockchains, develop your own blockchains that can have different trade-offs and have them communicate with each other. So how specifically that's going to interact with the end user, there's a lot of different ways, right? There are a lot of different things that blockchains can buy you in terms of security and privacy and especially transparency that via smart contracts that will be enabled by Polkadot, because it allows anyone really to generate and or use a blockchain. But that's a very broad question. So I would say it would really depend upon how much your mom knows about blockchain technology in the first place, because there are obviously a lot of different blockchain solutions out there. And but I think some of the benefits of ours really are the fact that you can have heterogeneous chains. That is, you can have different kinds of chains and not just the same chain that has the exact same trade-offs made. And also, it makes it very easy to communicate with other chains and bridge to other chains that already exist. Can the web app polkadot.js.org accounts manage multiple Polkadot wallet accounts? Yes, that is very possible. In fact, when we look at my polkadot.js.org, you'll see many different accounts. And we will look at that very shortly. And yes, it is unlimited accounts because generating an address is a pretty simple procedure. Obviously, any address that you want to keep has to have the existential deposit there, but actually having the accounts there, all that data is stored locally on your machine that you generated on. So it shouldn't. You should be able to generate as many as you want. There's probably some limit at 2 to the 32 or something, but any reasonable number of accounts, I'm sure, can be created with that app. Okay, good question. The reason for using the full 32-byte pub key as address data instead of deriving a 20-byte address from the pub key, it's a good question, and I'm not sure I have the answer to that. If you, yeah, the only thing I can think of, and I don't want to speak for Gav or whoever actually made this decision, but I would guess that the fact that we're using the index behind the scenes would mean that we don't need to spend as much time worrying about the space of the particular address. But if you do me a favor, email me, bill@web3.foundation. I can make sure to do some research into the rationale behind that. I just know that it is done. I don't know what the original rationale was, but happy to look into it and answer. That's just my guess on why it may be. So I don't want to put too much stake behind that, if you will. Okay. Yes, slides will be shared after this. Thank you. All right, so let's continue on. Share the screen again. All right, so another thing that I wanted to talk about is stash, controller, and session keys. So there, as I mentioned, there are different kinds of accounts and different kinds of keys. And one thing that's different about accounts, can be different about accounts, is the cryptography they use. But there are also things that those accounts do. If you're an ordinary user of Polkadot, that is, when I say ordinary user, what I really mean is you're not running a validator or you're not nominating, then really all you're going to have is a stash account. So this is a place that has long-term storage of dots. You can very easily keep this in cold storage. This is a regular old account. Okay. If you are validating or nominating, that is, and if you're not familiar with these, I recommend, we've got a lot of slides on the wiki about validating and nominating, and some of my previous talks were about being a validator on Polkadot and Kusama. So you may want to look into those. But basically, validating is the equivalent of miners. Not exactly, but they produce blocks on our network, and nominators are those accounts that can actually give money and stake rather to those validators to back them and share in the rewards from block production. If you are going to nominate, you actually need, or at least you're definitely recommended to have, two different accounts. A stash account where you would store your dots, and a controller account which could do the controlling for turning off and on validating or nominating, deciding who to nominate. Now with the controller account, this is going to have to be warm storage because you'll have to do things with it occasionally. If you have a controller account, you may want to turn off or turn on nominating, or decide to nominate different validators as time goes by. You certainly aren't going to want to have to go into cold storage to your bank safety deposit box and bring it out. But we want to get our rewards and put them in a safe place. So the controller account allows you to separate where you're actually storing your dots with how you are controlling the dots, how you're controlling what you validate and what you nominate with, etc. Finally, there are session keys. So session keys are not an actual account. There are multiple keys that are only really used by validators for doing things such as related to block production. These are in hot storage. These are going to have to be online and used all of the time. So that's one of the reasons why it's not an account, in fact. Those of you that have done some work with the Alexander testnet, which is running an older version, you may remember making session accounts. This is no longer necessary with Kusama and going forward because session keys have been separated out from accounts. So session keys are used by validators on an ongoing basis to do the work of producing blocks. So as we mentioned, people ask, people tend to be very confused. Why do you need multiple accounts to nominate? Well, you're going to have different security levels and different functions. It didn't really make sense to have them all be the same type of account. And the fact that session keys aren't accounts at all allows you to easily rotate them and make sure you don't have things that are session keys that are being stored for a long time, in hot storage. You may want to change them at certain points. So a session key, let's look a little bit more into depth. I already mentioned they're used by validators, but there are actually right now, with the latest version of the software, 4 different public keys that are part of a session key. That's why I put it in quotes, because it's really not a key, even though it is just one long string. It's a concatenation of 4 public keys. Just like with your regular account keys, the private keys are stored internally and not really exposed to the user. So the first key that's part of the session key is the grandpa key, which uses the Edwards 25519 curve. So that's for block finalization. The second is Babe, which is used for block production, and that uses our Schnorkel key, SR25519. The I'm online key is also SR25519, and that is how the validators indicate to each other that they're online. They use that to sign to sign their messages. And finally, there's another key for interacting with parachains, which is also 25519. So when you ask for a session key, and you can do this yourself if you make an RPC call to any node and call rotate keys, it's going to return a string version of the concatenated public keys. As I already mentioned, the private keys are internal. They're used only internally and only for validation. There's no need to ever expose them to the end user. An easy way to do this, if you are interested yourself, you can just call, connect to a node, or even just go to the default node on polkadot.js.org and go to Toolbox and call the author endpoint with the rotate keys function. And you'll see you get a very long string returned from that function. So here's just the example of the one that I got. Just looks like, you know, a huge number, but we can actually split that, and we can see where the grandpa key, the babe key, the I'm online key, and the parachain key. So again, these are used by the validator for different functions. And as I already mentioned, you can see they use different kinds of cryptography because for the certain types of functionality that they use, certain types of crypto are more or less secure for that particular functionality. And that's also the reason you can see that even though we have different keys for Babe, I'm online, and Parachain, you say, well, why don't we just reuse the same key since they're using the same cryptography? This allows us the flexibility if we do determine better cryptographic protocols to swap them out in the future, because they do have different functionalities and different cryptographic types are better suited for different kinds of actions that we do. So this is a how things stand as of now, as the code running on Kusama as we speak. However, just recently, over the last few days, an additional key has been added or to the code base, but has not yet been put onto the live, currently running live runtime, called Authority Discovery. So Authority Discovery is a key that's going to allow advertising connections to validators. Those of you that have set up validators, it's probably going to advertise your Sentry nodes as opposed to the main validator itself. I'm online. We haven't decided yet whether or not that will be used then for validators who aren't part of the active set, or it may be removed entirely. Again, that decision still hasn't been made. As I mentioned, the change is already implemented. It's on GitHub. You can look at it, but it's not in the current Kusama runtime. All right, so I'm going to stop again for a moment here. I don't see any questions this time, so I'm just going to keep going to our last section here. All right, so account generation. So if you recall, to generate an account, first you get some randomness from somewhere. That makes you make a seed out of it, and then you get a private key, a seed phrase, and a public key, which then gets converted into an address. So there are a lot of trade-offs in how you can do this. So, I mean, one of the key trade-offs that you have to make is security. How secure do you want this? You can do this in a very, very secure way, but it often will be less usable or less performant. Accessibility, how accessible do you want your keys? Usability, how easy is it to use? Performance, how quick is it? And flexibility, what kind of things can you do with it? So the first kind of way of generating keys that I want to talk about is subkey. So subkey is probably the most flexible way, of generating keys and storing them. Right now, the only way to get it is to build it. So if you get the substrate repo, do a cargo build, subkey will be generated for you. And subkey is a command line tool that, again, has a lot of flexibility, but that also means it can also be a little bit dangerous. You could do things incorrectly. But I wanted to start, you it can be very secure if you do it correctly, but could also be very insecure if you do it incorrectly. So generally, subkey should only be used if you have really specific needs. If you know that you want to do something in an air-gapped way and you want to have some specific, like a shell script or something that's generating keys in some certain way, then subkey would be very useful. But I would say for most cases, it's probably there are other ways that are going to be more secure and probably more easily usable as well. However, I think I wanted to start with subkey because I think it's very interesting. It allows you to really see what's happening. So when we generate an account and when we sign transactions. So I'm going to embiggen this a little bit, make sure everyone can see. I don't know how big the screen is on everyone's, how big everyone's screen is. So again, if you have the substrate repo, you'll have access to this. So to see what you can do, subkey-help. So you see, I have a couple of different things. I can go to different networks. I can use different types of cryptography. So let's just do something simple, like I am going to just generate a key. So it's going to grab some randomness from my system, generating a seed. You can actually see the seed here. Hold on. This long number. Let's make sure that this is visible to everyone. Okay. So this secret seed is just another way of saying this phrase. This phrase is just an encoded version of this. We have our public key here, and we have our final address, which remember has at the beginning here the network type. I just made a generic substrate key, and we have our checksum at the end here. Again, it's in SS58, which in base 58, so it's not going to map exactly to, like I can't say this character or this character because, it doesn't match up directly with the bytes. But if we, let's just quickly do a base 58 to hexadecimal, we'll be able to see that address hiding in there. So 708DF, we can see it right here, 708DF, ... And the 2A at the beginning, showing the kind of network. So what can we do here? Well, we can sign things. Okay, so we can sign messages with our private key, and then people can look at the public key and prove that it is in fact us that signed that message, which allows us to generate transactions. So I'm not going to get a full transaction. I'm just going to show you like the basic idea. So I have this secret phrase. You could use the secret phrase or the secret key for this. I'm going to echo a message. That was great. So that was great. And I'm going to ask subkey to sign this with my key. Again, I could just paste the secret seed there. It's excuse me, my mnemonic phrase. I could paste the secret seed number there. It's the same basic, same concept. So I now have this signature, right? And now anyone who has my public key, which is accessible via the address, it's easily obtainable via the address. It's part of the address. It's just squished in there. Is going to be able to verify that I, who know the secret key, the seed, which is technically behind the scenes is generating the secret seed, was the one who signed that message. So once again, I'll echo Bill is great, not Greer. And subkey verify. So first, here's the signature. And then here is my address, right? Which again, everyone has access to. So this is public. So, hey, signature verifies correctly. If someone else tries to change that to say, let's go back, and Bill is not great. No one, hopefully no one ever is going to say that. You know, signature invalid. Someone tried to fake it. Or if I say that it belongs to a different address, should probably get a real address here. That's probably not going to work as the checksum. Yeah. Hold on. Let me generate a new address here. Luckily, very simple. Subkey generate. So if I try to say, oh, right, this is, yeah, Bill didn't say that. I said that. Let's say the signature is invalid. Okay, so if we imagine instead of Bill is great, it's transactions, we can see that how we can sign our own transactions, and other people can, with our private key, and then other people can prove that it was us because they can verify with our public key. Okay, so that is, so subkey, as I said, generally is not useful for if you're trying to share your, if you're trying to use this on a day-to-day basis unless you have really specific needs. But on the plus side, it is a great way to understand behind the scenes what is happening. So what most people may are probably used to using is Polkadot.js, which I thought I had it here somewhere. Well, it's all right. I'll open up another one. Oh, there it is. So if you go to polkadotjs.org, /apps, sorry, /apps. There is a very powerful website that's going to allow you to do a lot of different things on the network. So I'm connected to the Kusama network, but you can also connect to other networks or even your local network. You can make your own substrate chain and connect to it locally. And I want to show you how to do this, but I first want to really specify that this is a very insecure way of doing it. So this is going, anytime right now I'm trusting a website that it is giving me the right data. It's not stealing any of it. It's not holding my private key. No one is man in the middle attacking me. You'll notice it is hosted on js.org. So this is not something that's on your local machine. You can, for a little bit more security, you could just download the repo and run this yourself locally. But it is possible to do this, but again, it is not the recommended way to generate accounts. But just to show you the basics, because I'll show you how to make it a little bit more secure in a moment, we can add an account here, give it a name, Bill Talk, whatever today is, 21 Nov. You'll see it got some randomness, made a mnemonic. I can do the raw seed, but generally it's not recommended we do the raw seed. Just because the mnemonic is easier to understand. It's more error resistant. If I accidentally typed in kangaroo and forgot the A, that's certainly something I can notice that I've fixed. It also has some built-in checksum. So generally use the mnemonic seed unless you have, it can be used for pretty much anything unless you have very specific needs. Usually advanced creation options we can ignore. As I mentioned, for a normal address, either Schnorkel or Edwards curve will work fine. I'm going to give this a password and save. It's going to back up my account as a JSON file, which I will not apparently accidentally open Xcode as well. And that JSON file is will only be accessible with that password. And anytime I am trying to send, I'm going to have to, on here, I'm going to have to type in that password. The next way I want to talk about is using Parity Signer. So to use Parity Signer, you're going to have, it's going to allow you to do air gap signing. So that's going to let you, using just an old cell phone. So what I mean by an air gap signing is right now with subkey, when I generated via subkey or when I generated via Polkadot JS, on the secret key is on the secret phrase, the mnemonic phrase, and thus the C, the private key, is somewhere on my computer, which means that it's possible that if someone was monitoring my computer, that they would be and computers have a very broad attack surface, right? A lot of different vectors that somebody could attack your computer and get into it. They would then have access to your account because they would be able to get access to your private key. And remember, there are no admins in crypto. So there's no one who can, if your seed gets pilfered and somebody transfers your dots away, you may not be able to get them back, barring force majeure or some major issue. There may be some ways, but generally you should assume that if someone has your keys or someone has your mnemonic phrase, that they also have total access to your account, which is generally not what you want. A phone, which is in airplane mode and not connected to the internet after installing the Parity Signer, is going to have a much, much reduced attack surface. And so what we can do is actually communicate with our phone and store our seed on our phone where it's going to be very safe. And the only things that would come into the only way we would access it is through a very well-specified interface, basically just reading QR codes. So very a much safer way and the recommended way to store any significant amount of dots that you would want to store. So how do we do that? I first installed the Polkadot Chrome plugin here. So you can see I have a few accounts here. And I actually took a picture because it's kind of hard for me to show in real time signing something. But if I want to make a transaction, and again, I have links to all of this stuff in the slides, which I'll share right after this. So I created an account, and you don't have to have that weird look on your face or the lens flare effect happening. It'll still work. So I made an account locally on my phone. So all of the randomness came from my phone. The seed is stored on my phone. And if it's something that I keep in airplane mode and turn off all the network interfaces, then I now have a very effective system. Then it's going to be very, very isolated from the rest of the world. And then every time that I'm asked to transfer anything or do anything with my dots from that account, then I can actually just scan the QR code, and I will read a QR code first from the computer that will explain to my phone what the transaction is that needs to be signed, and then my phone will sign it, and I can scan the QR code in as a response. So basically, I'm just going to use my phone to store the key that will never get exposed outside of the phone. Since any transactions will come into the phone to be signed, and then I will sign and send that data out, which again means that the only type of key that anyone ever could possibly have access to, unless they are somehow able to get into my phone, which again should be entirely air-gapped, they'll have no way of accessing the seed and thus accessing my account. All right, so those are just a couple of different ways for us to generate accounts and keys in Polkadot. I see that we have one question, so I'm going to answer that, and then I'm going to hand off this call to Chinmay Patel, who is CEO of BlockX, who's going to explain how his Enzyme Wallet works. But first, I'm going to answer, because I do see a question here. Two questions. So you can recover the address only with the signature and the content that is signed. If you have if you have the signature of something and the content that's signed, no, you would need the generally to recover the address, you can always make it with the key. I don't think by default that you can just with the signature and the content that's signed get the address back. Not that there may be some shortcut to do it, but as far as I know, that's not possible. When we want to update Parity Signer, we have to go online with our air-gapped phone. So hopefully, so Parity Signer is a pretty simple application. The general idea is it doesn't need to be updated after using it. That you would never update. You would have basically the equivalent of a hardware wallet. I mean, theoretically, if you want to be less secure, you could go online with the phone. But once you have installed Parity Signer, you should not need to update it again. If there really is some definite need to update it, something you can do is export the key, or hopefully you've written down what your key is, or you can. So what I mean by that is your mnemonic phrase, your seed, that you've written it down somewhere. You could then factory reset your phone, clear it all out, go online, get the latest version, and then go back off entirely. All right, so thank you very much. As I said, I am going to hand off the presentation to Chinmay here. So just give me 1 second here to invite him.
Okay. Am I audible to everyone?
You're audible to me, so I'm going to let you take it away.
Perfect.
Getting off here in a second.
No worries, take your time. Okay, I'm not sure if people can hear me. I'm gonna share my screen as well. I'm trying to find out where that is. That's share. No, that's a wrong share. Where is share? Oh, right there. Toggle video, HD, share screen. Okay, I need a confirmation from someone in the chat that they can see the screen. Okay, perfect. Got it. All right, so I'm gonna move to quick presentation. This will be like less than 5 minutes presentation just to give you idea of what we have built so far. And after that, I'm gonna jump into the demo. I have 2 demos for you. One is what we are working on, we call Enzyme Wallet, which is a browser extension wallet. And there's another thing that we are working on called Universal Wallet for multiple blockchains. So hope if we have time and if we have more interest, I'll go into that demo as well, which is much more interesting. But just to start with it, just a little bit of background about myself. So I've been a developer for over a decade before I started this company with the idea of creating basically services shop for highly technical workflows. So we started with APIs, we started with microservices development. We got into blockchain roughly a couple of years ago when a friend of mine reached out to me for a smart contract help, and we picked up Solidity development. Fast forward 2 years, we are roughly 15 people, dev shop based in Toronto, focused on mostly blockchain work these days. This is our basically mantra we go by. If you make anything easy to use, it was the best way to consistently and cheaply innovate and drive adoption for whatever technology. But right now we are focusing on blockchain mostly. So let's take it to blockchain only for now. These are all the platforms that we have worked on to some extent. Some are as basic as just deploying a smart contract. Some are as intricate as building the blockchain from scratch and taking them to testnet. So we have a wide array of work that we complete. Custom wallet solution is becoming quite popular. People reach out to left, right, and center to build their wallet solutions because something we have expertise on, and we have done it multiple times, whether it's a desktop wallet, browser wallet, or a mobile wallet. We do custom blockchain development using Substrate and Rust as well. So we are working with potentially a parachain. It's not a parachain right now, but potentially a parachain, and building their testnet from scratch, and some other token creation, audit, product development kind of work. So let's jump into the real meat now. So in terms of while building the browser extension for as a wallet, we had prior extension to build prior experience of building to the browser extensions themselves. Like I personally had built a couple of them in the past, so we knew what kind of complexities that we ran into. So before we even started building, we kind of come up with like ground rules that we wanted in order for our architecture to accomplish. So first of all, private keys are always encrypted at rest and in transit. They are only decrypted for signing that message in memory and then removed right away. So that's something we are very, very, very careful about, that the private keys are not visible to anyone, literally anyone. And especially it's exposed only for that particular window for signing message, even to the application, and then removed right away. So no other dApp or no one can really access it. So that comes down to the second part, which is dApps can never access the private keys itself, like never ever. So there is a special architecture that browser extensions allow, and we went to the extent, like a full extent of it, in order to make that happen. And the most important rule out of all of them is users have the full control. So at the end of their user experience, they should be able to remove, create, extract, import the private keys however they want, because apparently and finally it's their private keys. So these are the three major considerations we had to be mindful of before we even started working. In terms of browser extension, this is a little bit, I'm going minorly in detail of how browser extensions generally work. So, and see this as a window. This is taken directly from the browser extension documentation by Chrome. So I forgot to cite it. Sorry about that. I'll when I put it online, I'll definitely cite it. In terms of popup.html, it's more like when the user wants to interact with this as browsers, and when they open up a window like this or this, it is simple HTML page with a JavaScript injected as part of it. It's called popup.js. That is at the time when the browser starts until the end, there is something called background.js. It's basically the full scope of the extension from the installation to until you uninstall it. The scope remains. Of course, when you close the browser, it comes back up and bring it up back up. So that's when the background.js scope is. And the most important part for us to understand is content script.js. So content script.js is where you inject this JavaScript into a browser tab. So whether it's a Crowdcast tab, whether it's a Medium tab, whether it's a Google Sheet tab or any other tab. So content script is the JavaScript injection. We inject Polkadot.js custom object inside each and every browser tab, so that browsers or the dApps can interact with the Polkadot.js that interacts with the background.js, and inside that background.js you have all the private key and everything stored. So this is a little bit, I don't have much time to go in much more detail, but hey, if anyone wants to get into any of this discussion, this is one of my favorite topics. So just either put it as a question and I'll make sure that I give a detailed answer, or reach out to me directly and I'll definitely answer those questions. So this is the intricate part of how browser extension work. Let me jump into the demo of Enzyme. I'll start from scratch by installing, and while making the demo work, I'll be explaining what is really happening from the content.js perspective and the background.js perspective and the pop-up HTML. So just to start with, and if you want to follow along, I'm going to copy paste this inside the chat window. So from here, I'm adding it to the Chrome, add extension. So let's wait for a couple seconds. All right, done. That was fast. So once it's installed, you can open up. It's a very similar MetaMask-like experience for the first version. In the next version, we will be making some modifications going forward. So if you know MetaMask, this will be a very familiar UI with minor nuances specific to Polkadot. So of course, terms of use, you have to go all the bottom, you do it. So right now, popup.html is being run. And in the background, background.js is working since we installed it. So let's make a password. So this is the password that will encrypt the private key at all stages. So before even we create the private key and store it anywhere, we make sure that it is a password. So the moment we have the private key, we encrypt it right away. So for the simplicity's sake, and please do not use it, I'm making the password, and it doesn't like it, so I'll probably do 1, 2, 3 on top of it. Password 1, 2, 3, create. So this is what Bill was talking about. It creates generated seed phrase. I'm gonna copy it, click copy. At the same time, there is an option which is of course advanced, whether you want to create add or you want to create snorkel. You can create a nickname for this. Let's just create live demo 21st November. Next. Oh, it has to be less than 12 characters, my bad. And now I just confirm the same seed phrase. Definitely make sure that you save it somewhere secret. Generally, I would write it on paper and literally put it in my locker. That's what I've done with other ones. So let's go with it. Generate. And then boom, you have a wallet. You have a wallet with the value. You can see, like, if you can click receive, and then you can store this address or give it to your friends or clients for the payment. You can send, but we don't have anything right now, so we can't send. Right now, everything again. When we clicked on create, we moved from content script. We moved from popup.js to background.js, and background.js encrypted all the things right away. So that's the main piece behind it. Let's send some money here so we can do another transfer. So here I have created another account on Polkadot.js website. Let me just send some money to that particular wallet. Come on. All right. Amount 0.01. Demo account. You have this one, so make transfer. Okay, so it's transferring. We should be able to see the balance the moment it goes from here. I can see someone typing as well. I'm gonna go check meanwhile. Okay, not sure what is, I think you need to send the, also Alexander has been slow lately. Okay, so for now, let's assume that it has worked already. I don't know if it would show up here or not. Damn. Yeah, no, it is really slow. Okay, nope. Okay, unfortunately, we're running out of time. How do you want to handle that, Bill? Do you want me to go into Universal Wallet, or we can keep it for the next time, or can we just extend 5 more minutes? Yeah, let's do it. Good point. Does the user need to type in PK encryption password for every sign operation? So no, not for every sign operation. They don't need to do password, but after certain amount of inactivity, and I believe it's 300 seconds, so roughly 5 minutes. After 5 minutes of inactivity, you will have to put in your password again in order to access this extension or to sign messages going forward. So not every single time, but after a certain timeout. So in the next version, we have I believe we are working on a settings where you can have your own settings page. Okay, so this is taking a little bit of time and not showing up. Let me just quickly do a very small intro to Universal Wallet or what we are building. So in here, this is not publicly available right now. So if anyone wants to access it, send me a message and I will be able to get it off to you. I'm basically installing an extension as a developer mode. So load unpacked extension on my local machine. So desktop, demo, Polkadot. Damn it, where is that particular thing stored? So load extension, Chrome, select folder. So the moment I install it, a new thing shows up. We don't have a new design or anything, but this is basically, in a nutshell, the similar wallet that can handle multiple blockchains. So the moment you agree with it and create a password, you can add an account and you can pick any of the 5 blockchains that we are supporting right now, including Bitcoin and Ethereum. Kusama Edgeware is already there. So I can, let's just say for the sake of this transaction, we can create Kusama in here, nickname, Kusama, next, confirm, confirm, and I have a Kusama. Now, if I want to interact with Kusama, we took that whole experience out of the wallet and put it as a built as a dApp. So now we are basically dogfooding our own product. And now I can send transactions. Of course, I won't be able to show you the send right now. I don't have money in Kusama, and send module is in flux. But I can show you the sign functionality. So this is the dApp. Through content script.js, we have injected a Kusama wrapped Polkadot.js object as part of this tab. And now this tab can sign any message they want. So let's just say, let's just go with the same. Bill is great. Same message, sign it. Sign it, and it will, with a couple seconds wait. And then you sign it. And then, of course, this is all the hash. And right now this is why it's not public yet, because we are working on it. But now you can have the same thing for Ethereum, Polkadot, and all the other ones. And there are no accounts created. So it will just ask me to create an account. So this is a short version of the Universal Wallet. I'm sorry I had to rush on that. But if anyone has any questions, they can. I'm going to put my email here. And they can just directly message and I'll be able to answer. So that's a short video. Let me see if money is in there. Otherwise, we'll just move on.
Yeah, I think we need to end, Chinmay.
Okay, let's do it then. Thanks, Bill.
Right. Well, thank you, and thank everyone else for showing up and listening today. As we mentioned, the slides and this presentation will be online. I think maybe Dan or Hutch can paste the link. But it should be at the same link, crowdcast.io /Polkadot keys. Oh, actually, I could do that. Give me 1 second. I'll paste that. So if anyone else wants to see this afterwards, please feel free. All right. Have a good day, everyone.
All right. Take care.